So welcome back again to Sami KMF Mathematics. In the first two videos I discussed the concept of trigonometry and the subtopic the right angle triangle, and we solved a problem where we solve a particular triangle completely. So we are going to be looking at another problem right now. The problem is simply saying if theta is acute. So I will roll over this page and we'll get another question. I believe if you have any problem concerning this, you can always check the former page. So the question is saying if theta is acute. So the information about theta is that it is acute. So if theta is acute and we have tan theta to be equals to 3/4. The question is we are to evaluate. So we are to evaluate sine theta plus cos theta. So that is the problem there, right there. So we have to evaluate it, but we don't know anything about this. The only thing we know about this is that sine theta is opposite over hypotenuse. We also know that this is adjacent over hypotenuse. So these are the basic information we have concerning these basic trigonometric ratios. So what we are looking out for is the good information here is that theta is acute, and so it gives us an idea that theta is between 0 and 90 degrees, and that can be embedded in a right angle triangle if we are looking at it in the quadrant. So if this can be represented in the quadrant, we can pick this out from the quadrant like this. So we're going to be having something like this, where this is more like the radius, this is more like the angle, which is acute, but we don't have any information more than the fact that it is acute. And looking at it from the quadrant, this is the y-axis, and this is also the x-axis. So we can look at it this way as that. And this gives us an idea that this definitely is going to be a right-angled triangle. So what do we do right now? We know that tan theta, recall that tan theta is the same thing as opposite over adjacent. So this is a good information. And if tan theta is opposite over adjacent, and tan theta here with respect to this angle is 3/4, it's obvious that the opposite, comparing the ratio, so comparing these two ratios, it's obvious that the opposite side, which is the vertical side, is going to be 3, and the adjacent, which is the horizontal side, is going to be what, 4. So that can help us to find the other side, which is a hypotenuse. Now we have this as 3 and we have this as 4. The next thing we need to do is to find this hypotenuse, and that we can do with the Pythagoras theorem, because the Pythagoras theorem is simply telling us that the square of the hypotenuse is the same thing as the opposite square and the adjacent square. So you can use this as a simple abbreviation so that you can remember this easily. This is not 0, so you can put this so you don't confuse this to 0. All right, so it's obvious that this is our hypotenuse. Our hypotenuse is not known now, but our opposite is known. Our opposite is 3, so our opposite is 3. So we have that as 3 squared, and our adjacent is 4, so we have that as 4 squared. So that's we can solve that out to 3 squared is simply 9, and by our indices, and 4 squared is 16, which you can add to give us 25. So we have our hypotenuse squared to be 25. So we can take the square root of both sides, more like looking for a way to take out these 2. So find the square root of both sides to get our hypotenuse to be square root of 25. That's plus or minus 5, but we'll take plus 5. So we take plus 5, not minus 5, because length can't be negative, the scalar measure. So we have the hypotenuse right now to be 5, so this is now 5, and that can help us to find this. So our sine theta will simply, our our opposite is 3 divided by the hypotenuse, which is 5, plus our adjacent is 4 divided by the hypotenuse, which is 5. So we can simply add this. We have common denominator, so that's easy for us to add the numerators, and we have 3 plus 4, which is 7 over 5. So that is the value of this. So it means sine theta plus cos theta. By respect to this, please, with respect to this being this, is simply 7 over 5. Please take note of that. So I can give an exercise to also evaluate. You can evaluate 3 cos theta minus 2 sine theta. So this is just an exercise for you, knowing that theta is acute and tan theta is also 3 over 4. This is basically one of the fundamental area that is required in trigonometry and solving right angle triangles. Thank you very much. Subscribe and share.